Hello everyone, my name is Bich, and in this video I will show you how to use the analysis tool on WaPOR portal. You can use this to extract point time series, area time series, or water productivity raster of an area. I will now demonstrate how to extract time series data for a point on WaPOR portal. We can do that using the analysis tool on the left corner here. Before clicking on the Analysis button, we need to change to the data layers that we want to extract time series. For example, now we are looking at the gross biomass water productivity. If you want to extract monthly actual evapotranspiration and interception, you will need to click on the Layers button and select actual evapotranspiration and interception monthly. To extract time series data, you don't need to change the month layer, so we can leave it for now. After that, we can open the Analysis tool and select Point Time Series. Now, under the Place tab, click on Select Point. You can either select a point that you have saved before or add a new point. Under the New Point tab, you can fill in the latitude and longitude coordinates of the point you want to extract time series data. For example, I have this point, and then click Select. To save this point for later use, click on Save in My WaPOR. You will need to sign up for a WaPOR account and log in to do this. Then give the point a name and save it. Now under the Time Period tab, you need to specify the time period you want to extract time series. For example, let's extract data from 2009 until the end of 2010. Similarly, you can save in my WaPOR this time period. Let's name it period 2. After that, click Run Operation. It might take a while to process, depends on the internet connection. Then you can have this graph of monthly data for the selected period. To save this time series data, you can click on the button on the right corner of the plot and choose Download CSV. And then a CSV file is downloaded. You can click on this to open in Excel, for example. Here we see the date and the value separated by comma. So I will convert text to column in delimited mode to separate um, the date and the value by comma. After that, you will have two columns of data. Now go back to the portal. In case you don't have the exact coordinates of the location you want to extract time series, you can use the Locate tool to search for a name of city or place of interest. For example, now I will search for Bekaa Valley in Lebanon. After that, the portal will show a point in Lebanon Valley. Sorry, in Bekaa Valley. Another way is to click on any point on the map. For example, I want to select different points in Bekaa Valley. Whichever point you click, you can choose point time series to open the same analysis window and follow the same step to generate time series. I will now demonstrate how to extract time series data for an area on WaPOR portal. First, you need to make sure that you are selecting the data layer that you want to extract time series. In my case, I want to extract time series data for actual evapotranspiration and interception monthly. Then we can open the Analysis tool and select Area Time Series. Under the Place tab, click Select Area. You can choose an area that you have saved before in the My Areas tab or adding a new area. You have two options. One is to draw and second is to upload a shapefile. If you want to draw an area, click on Draw. Here you will start drawing the area that you want to extract time series. When you click, you can select a point and drag to draw new lines and continue until the last point is connected to the first point, creating a closed boundary. You can also save this area for later use using Save in My WaPOR button. If you have a shapefile of your area, you can choose Uploading a shapefile. Let's try that by select a new area. Here we need a zip file that contains a valid shapefile. For example, I have these shapefiles with the mandatory extension files. I will select all of them and send to a zip file. After that, back to the portal, I can click Choose and select the zip file and upload it to the WaPOR portal. Here I'm asked to confirm the geometry. You will need to check the shape and the location on the map to make sure that the shapefile is correctly uploaded. After that, we can click Confirm. Now I will save this new area as Zinavan. After that, you will need to select a time period to extract data. This is similar to point time series analysis. For this, I choose the time period that I have saved before. Then I can click Run Operation. On the right corner, you can see the status of processing. Once it shows completed, click on the green button. Here you will receive the time series data for the area, so there will be three values, average, and a range from minimum to maximum. Similarly, you can click on the button next to the plot to save CSV file. I will now demonstrate how to calculate crop water productivity rasters for specific crop area on WaPOR portal. You can do this for an area of crop where you know the crop specific parameters. For this example, I'm going to use the national 100-meter data layer. I will open the analysis tool and select area water productivity. In the Place tab, click Select Area. You can create a new area or use an area you have saved. In this case, I will use a shapefile of sugarcane crop in Zinavan. Here you can see the plots of sugarcane. Now in the Time Period tab, you can choose the start and the end date of crop season. For example, in my area, the crop season starts approximately from 1st of October until the last day of September of the next year. Therefore, I will select the period from 1st October 2009 until 30th of September 2010 for the crop season starting in 2009. I will save it as Season 2. Under the Advanced Option tab, you can customize the crop-specific parameters to calculate crop water productivity. These are light use efficiency, LUE, harvest index, above ground over total biomass ratio, and moisture content ratio. You can also refer to the explanatory notes for details of the computation. In these notes, you will find the definitions of these crop parameters and the formulas used to calculate crop yield and water productivity rasters. Back to the portal, in the select crops list, you will find some common crops types. If you choose one of those crops, the reference values for crop-specific parameters will be automatically filled. For example, in my area, the crop is sugarcane. So when I select sugarcane, you can see the common values for sugarcane crop parameters are filled. Here, the LUE value for sugarcane is 1.8 since it is a C4 crop. If you cannot find your crop in the select crop list, you will need to determine the crop parameters of your crop type either from literature or field measurements. After filling the crop parameters, I can click Run Operation. Once the processing is completed, you can click on the green button here and you will see that there are 3 links to download 3 rasters. In the explanatory notes, you will find the explanation of these results. The raster with AETI code is the total actual evapotranspiration and interception of the crop during the selected season in cubic meter per hectare. The raster with TBP code is the yield generated from the growing season based on the specific crop parameters in kilogram per hectare. And lastly, the raster with GBWP code is the crop water productivity. Notice that this has a scaling factor of 1000, which means after downloading the raster, you will need to divide the raster by 1000 to get the value in kilogram per cubic meter. For example, now I will download the crop water productivity rasters. I can open this raster in QGIS. Here I add a raster layer and select a downloaded crop water productivity raster. After that, I can use QGIS raster calculator to convert the downloaded raster into kilogram per cubic meter by divided by 1000. Then I will save the result raster. And that is the end of this demonstration. If you have some questions, please ask in the Q&A session. Thank you.